Hello everyone, welcome to today's class. Today's class we're going to be doing an introduction to partial fraction. Some of you might have found this topic challenging in time past, but after this series of tutorial videos, I believe that you'll be able to attempt partial fraction confidently. And let me start with this simple expression. This is an algebraic fraction. I get it, man. These are algebraic expressions, and we want us to add them together. I know you could have performed something like this, you could have done something like this, very easy to solve. So let's attempt this particular expression. So you simply know that you have to find the LCM of the denominator of both expressions. And in this case, you just simply write out the two expressions and put them in a bracket. So you have x minus 2 and x plus 1. Then you follow the LCM. You follow the same principle we solve using the normal fraction. In this case, x minus 2 is to divide this. We'll be left with x plus 1. So we'll have the 1 multiplied by x plus 1. We don't necessarily have to write the 1, since we know that we still have the same expression if we multiply. So we can eliminate the 1. So put our addition. The same thing, we divide this by this expression. We left with x minus 2. So this will be 3 into what? X minus 2. The next thing to do is to expand your bracket for the sake of this one on top now. So if you open our brackets now, we have x plus 1 plus 3x minus 6 over x minus 2, x plus 1. Now let's collect the like terms here. We have x plus 3x plus 1 minus 6 over x minus 2, x plus 1. So what we have here is 4x minus 5 over x minus 2, x plus 1. Before we let us expand this expression here, let's expand it. So what we're going to have is 4x minus 5 over x. So we're going to multiply. So x times x is x squared. X times 1 is x. This times this, that's minus 2x. And minus 2 times plus 1, that's minus 2. So we are ending up with 4x minus 5 over x squared. If you add the relevant ones, you have minus x minus 2. So it simply means that the addition of these two expressions will give us this expression. So, which is what I've written here earlier. I get me, I've written this earlier, but I'm just showing the process of how I arrived at this. Now, the principle of partial fraction is such that we are going to be given this expression, and we're expected to resolve it, and we're expected to work it back on what are the two or more expressions that made us to arrive at this answer. What am I saying? So they can give you, let's say for instance, we don't have added these two together to arrive at this particular answer, but how do we now split this particular expression to give us these two individual expressions? That's the principle of partial fraction. We are splitting the whole expression like this into two or more components, depending on what kind of expression we are dealing with. In this case, are you getting me now? So in the next couple of videos, we are going to be doing some examples, but there are some important principles to note before we continue. For you to be able to perform partial fraction on any kind of expression, the first thing you must notice is that the denominator must be factorizable. That means that you must be able to obtain factors for the expression in the denominators. I get what I'm trying to say now. That means that if I use the factorization method, we have looked at solving the quadratic equations using a factorization. That means that every denominator in the equation that involves partial fraction must be factorizable. We must be able to obtain factors of the denominators. The second most important thing that you must notice is that the degree of your numerator must always be lesser than the degree of your denominator. That means that the highest power in your denominator, the power in your denominator must be greater, at least by 1. In this case, this is just a linear expression, this is a quadratic. So that means that this is lower than this expression, at least by a factor of 1. In the case where they have the same power, you have to first perform a division. Or in the case where the power of your numerator is greater than the power of your denominator, you have to perform the division of a polynomial to arrive at a more favorable factor. So before you can move on with factorizing an expression in partial fraction, the first thing I mentioned is that what? The denominator must be factorizable. You must be able to obtain factors of the expression, and number 2 is that the power of your numerator cannot be greater than the power of your denominator. It must always be lesser before you can move on with your partial fraction. In the next couple of videos, we're going to look at the various ways that your partial fraction questions can exist, and we are going to be looking at how to solve them. But before we move on, there is a general, for the first way, or the first method we are going to be looking at the example at the next time. We're going to be having, so this kind of expression, when we want to split it now, we're going to be having, let's say we have 4x minus 5 over x squared minus x minus 2. So we're simply going to say a over whatever we have here. Okay, we'll still get to that point, but let me just take us ahead of the class. So in the next tutorial video, I'm going to introduce to you how to solve the various methods that you have under partial fraction. I believe this introductory video has given you the pace and has prepared your mind for what we're going to be having in subsequent videos. Remember to share with your friends. This will going to take them a long way in solving every question under partial fraction. Thank you.